Hi, so I'm Amaya Gonzalez from 4th period, and I chose to do the learning objective 3.B.2.1. So I chose a problem from 1998. Okay, so the first question is determine the acceleration of block B as it descends. And the first step to solving this is making two free body diagrams, one for A and one for B. For A, it's going to have normal force up since it's on a tabletop, force of gravity down because of gravity, and the force of tension to the right because that is the direction the string is in. So B, let's try right here. It's going to have force of tension up, the force of gravity down. As you can see, the force of gravity larger than the force of tension, and that's because when it's released from rest, it should accelerate downwards, so the force of gravity should be larger than the force of tension. So now, to find the acceleration, we have to use Newton's second law. And in this case, the net force is going to be the force of tension also, because the normal force and the force of gravity, they should cancel each other out. So we know F net here. Now we have to make it here. So F net should be the larger force, or MA, sorry, and then the larger force, which is the force of gravity, minus the force of tension. So now that we know the F nets, we can solve because force of tension is also equal to mass times acceleration, so we can plug this right here. So we can make this MA equals force of gravity minus MA. Acceleration would be G over 2. So part B says block B strikes the floor and does not bounce. Determine the time t equals t1 at which block B strikes the floor. Okay, so to begin this, we need to figure out what we know. So we know that block B is a distance h above the floor, and we know from the last problem that it has an acceleration of g over 2. So we can plug those in to this equation right here, a kinematics equation. Okay, so if you remember, it said that the block was released from rest, so it has no initial velocity, and we can say that y initial is 0. So we need to solve for t, so y equals 1/2 a t squared. T1 is equal to 2 square root of h over g. It says for part C, it says describe the motion of block A from time t equals 0 to the time when block B strikes the floor. So to first begin, we should redraw the free body diagrams. So both of these blocks are going to have the same tension since they're both attached to the same string. So whatever happens to over here will happen over here. So block B, when it's released from rest, it's going to accelerate downward, as we found out with an acceleration of g over 2. So because of this, because block B is accelerating downwards, that means block A will also accelerate downwards with an acceleration of g over 2. So the motion that block A will have from time t equals 0 to the time when block B strikes the floor will be an acceleration to the right, and the acceleration would be g over 2, since B also has an acceleration of g over 2. However, in part D, it says, describe the motion of block A from the time block B strikes the floor to the time block A leaves the table. So when block B strikes the floor, we'll just redraw the body diagram and the normal force, because the force of tension isn't applying any force anymore since block B is on the ground, and it doesn't need to be held up or anything. So there's only the force of gravity and the normal force, and they will be in equilibrium because when block B strikes the floor, it's going to stop moving. It'll have no movement, so it's going to have no net force, no acceleration. So what that means for block A is that there's not going to be any force of tension anymore, since block B is not applying any force of tension. So the new free body diagram for part D for block A will be just the force of gravity and the normal force. And And because these two are both have the same magnitude, that means that block A will also be in equilibrium. However, it will be moving at a constant speed since it was moving before already.
Oh.
And E says, determine the distance between the landing points of the two blocks. So to begin solving this, we can use the kinematics equation V y b equals v y b 0 plus a y b t. We know that B was released from rest, so it has no initial velocity. So Vy b equals a y b t. So Vy b is going to be gh, which is also going to be the initial velocity, initial horizontal velocity, since it's moving on the tabletop horizontally, of A. So now we can plug this, since we know the initial velocity, we can plug it into another kinematics equation to find the horizontal distance. It's moving horizontally, so it's going to have no acceleration. It's moving at a constant speed, no acceleration. We can make this 0 also, so x equals v x a 0 t. Okay, so and now we need to find t. Okay, so then plug that into another kinematics equation. How fun. Y equals y 0 plus v y 0 t plus 1 half yt squared. As block A leaves the tabletop, as no vertical initial velocity, so we can just cross it out, cross this out. So we can solve for t for now. So that's 2h over g, surprisingly the same time as the other one. So we can just plug in what we know now into this equation. We know t, and we know the initial velocity. So just gh h over g. So x equals 2h. There we go. And that should answer all of the questions on here. Thank you for watching, and see you later.